say, for example, we have x, let's say we have xy plus 3xy here. So the reason why we would call these like terms is because both of these variables have the same amount of exponents. So these variables have exactly the same amount of variables. If there is no number in front of the xy, how many xy's do I have? Right, I have 1. So in this case, it would just become 4xy. A very simple problem. I would just be done. That would be simplified. That's it. Okay, let's start to increase the difficulty here. So we have So in this case, we want to match everything so they're exactly the same except for the number in front. So the coefficient, which is the number in front, just tells us how many of this object there are. If you wanted to visualize what this looks like, this would just be saying there's a shape with a side of x, and then another side of y, right? A side of x, 2 sides of y, so y and y, which would make these two actually different from each other. Okay, so the biggest, I would say the biggest help for this chapter is attention to detail, right? The biggest thing for this chapter is attention to detail. You have to make sure that everything matches up exactly the same. So in this case, here you can see that the x's, they are the same. However, the exponents are not the same. So these are not like terms. These are not like terms. If I look at my next one, you can see that, well, the x's, they're both squared, and the y's both have no exponent or an exponent of 1. You could see that, okay, there's a difference in the coefficient. But again, the coefficient just tells us how many there are. So that means we can combine these two. And this will just be 9x squared y minus 3xy squared. And that would be it, right? We cannot combine anything that's not like terms. In a way, this is like counting how much of each object we have. You can consider this as number of apples, and this would be number of pears, right? When you're a kid, you might think that they are exactly the same because you're like, okay, they look like the same kind of object, but later on you get the wisdom and you know that apples and pears are not the same, right? Even though they look the same. Okay, so really this basic idea drives most of this chapter. This chapter will eventually go to multiplication, but that's going to be on Monday. Again, today I just wanted to leave you guys with an easier lesson. The second idea is what we call distribution. So we can have something like this where you have 3xy squared plus 6x squared y minus negative 3xy squared plus 10x squared y. So in this case, you have to be really careful. We want to compare and combine like terms. Before we combine like terms, you want to make sure and distribute any negatives you see, right? If there is a parentheses, you must distribute that negative to everything inside the parentheses. If, however, there is a plus sign, you will not distribute that plus sign and change a negative sign. It will still remain a negative sign. Okay. So in this case, I'm just going to go ahead and rewrite this as 3xy squared plus 6x squared y. And this is a negative 3xy squared, so this changes to a plus 3xy squared. And this was a plus, and this will now change to a minus 10x squared y. You can see here that the like terms are this one and this one right here, and like terms are this 6x and negative x squared. So again, all I'm doing is I'm combining what we call like terms because they're exactly the same. They match up. The variables are all the same, and then the exponents match up exactly the same. So in this case, all I'm doing is doing 3 plus 3, which is 6xy squared. And this one is 6 minus 10, which would be minus 4x squared y. Okay, so something to note, and this is something I mentioned, but how we order these is generally actually by the variables. In this case, where there are multiple variables, the order can be kind of convoluted, but generally we're actually going to put the one with the biggest x first, and then we're going to put the one with the biggest y second. The reason is alphabetically x squared, x would be first, so we're actually going to put numbers with the biggest exponent first. So even if we have something, so let's just say we have another problem, we have x to the 10th minus 20x squared plus 40x. This is actually in the correct order because the largest exponent is x to the 10th, and then the next one would be x squared, and then the next one would be x. So we place them in order of the greatest exponent. So we place them in order of the greatest exponent.